All right, guys, today we're going to talk about some ratios. And the first thing that we're going to do is we're going to talk about how to set up a ratio. So what is a ratio? Well, a ratio is just a comparison of two quantities. All right, so we're just comparing two things. So chocolate chip cookies to oatmeal cookies, cheerleaders to pom-poms, miles to gallons. We're just comparing two different quantities. So there are different ways to write ratios, all right? And our first and most common way is going to be A to B. All right, A to B. And that's just going to be used with that colon. And it's going to look like that, A to B. All right, and then the second way we might see a ratio is we might see it as a fraction. And so first number A over second number B. And one of the big things that's really important for ratios is that order matters. Okay, so we want to make sure that we are putting things in order. Another way we might see it is we might see it with the word to, A to B. Okay. And the last one is per. So we might see the word A per B. Okay, so those are all the different ways we might see ratios. We are going to focus on our first two here. These are going to be our most common, and we may read it like this, but we're going to write it like this. All right, so we have example number 1 at the top is just showing you all the different ways. So again, we have our, remember, order matters. So if it gives A first, we need to put A first. We are going to label. Labeling is so important. And we are always going to find our total. Okay, we're always going to find our total. And total is just adding. So we would take A and add B to find total. All right, so let's look at this example of different ways to write ratios. So we have a bag of 3 purple marbles, 4 green marbles, and 5 blue marbles. So they want the ratio of purple to green. So I am going to say, well, purple was 3, and it goes first because order matters. And then in the middle, we have our colon. And then green was 4. Okay, 4. And again, that is our most common way to see a ratio, but we might also see it like a fraction. So I could also write it with 3 to 4 that way. All right, and then our next one that they're asking for says blue to total. So in the problem, did they give me total? They didn't. So I have to take my purple, my green, and my blue, and again, I'm going to add them together to find total. So I am going to grab 3 purple plus 4 green plus 5 blue, and that is going to equal 12 total marbles. Okay, 3 plus 4 is 7, 7 plus 5 is 12. And so now I'm ready for blue. How many were there? There were 5. Remember, that goes first because blue was first and order matters. And then we have our colon in the middle. And then we have how many total? 12. 12 total. And again, remember, we could write that as a fraction. So blue over total. Okay. All right, so let's apply that ratios knowledge to example number 1. All right, we've already learned skip counting a little bit, so that's what we're going to focus on today, skip counting and butterfly. All right, so it says Miranda mixed 4 gallons of blue paint. So I'm going to underline 4 gallons of blue paint with every 7 gallons of red paint in order to make purple paint for her walls in her room. Which ratio of blue to red, so remember, it's really important that we look at the question mark statement and we see what order. So we have blue paint to red paint. So we need blue to red. That's our order. So my ratio, when I come back up and read, blue was 4 and my red was 7. So that's my ratio they gave me. Again, order matters, so I had to put it 4 to 7. And then it says which ratio will make the same shade of purple paint. And when they say the same shade, they're literally just mean which one is going to be an equivalent ratio. And so we have a couple options when we are solving for ratios. And the first one is skip counting. So I'm going to skip count my numbers 4 and 7. So skip counting just means counting by that number. So blue was 4, so 4, 8, 12, 16, 20, 24. So that's a pretty good list right there. All right, and then for red, we're going to skip count 7s. Okay, so again, we're just counting by 7. 7, 14, 21, 28, 35, and 42. So these are all equivalent ratios. And again, we could write them as fractions. That could be 4 over 7, 8 over 14, 12 over 21, so on and so forth. So I would check my list and see if any of them match. Well, I know that this fraction here is a Joe Schmo. This ratio is a Joe because order matters. Okay, order matters, and it is out of order. So even though it kind of looks like this ratio here, it is out of order, and so we know that order matters, so that's a Joe Schmo. All right, so I check my list, and I say, okay, well, what about 12? Did I have a 12 at the front? Yeah, I did. What was behind it? 21. Is this 21? No. So that's probably not going to work. All right, let's see. Did I have a 48? I did not, but I could keep skip counting down my list of 48. All right. Did I have a 10? I did not, but 10 would fall here, and it does not fall in the, it doesn't fall on my list. And so if the 10 for blue, right, that first number is a 10, if I don't have a 10 on my list, then it cannot be the answer. So I'm pretty sure my answer is C. So if I kept skip counting, would I get to 48? I would. So how can I double check and make sure? Well, the easiest way is to butterfly. So I'm going to take my original ratio of 4 to 7, and I'm just going to put it underneath. And I'm going to butterfly. So I'm going to say 7 times 48 and 84 times 4. All right, and 7 times 48 is 336. And 84 times 4 is also 336. And so those do come out equivalent, and therefore C is going to make the same shade of that purple. Okay, so again, if we wanted to keep skip counting our list, we could go all the way down to 48, and we could go all the way down to 84. And what you should notice is that this relationship here is actually just times 2. So you can see for 24 times 2 is 48, and 42 times 2 is 84. So we could get there by skip counting, we could get there by finding the relationship, like the times 2, and we could get there by butterflying to see if they come out equal. Remember, the big thing is that the order matters, okay? And you notice I did label my blue and my red, okay? All right, let's look at example 2. So example 2 says the ratio of cats to dogs at the animal shelter is 8 to 3. Create a list of equivalent ratios, including the total, by filling in the table. So it says the ratio of cats to dogs. So I know cats is first. So I'm going to label that 8 with a C. And it says dogs is second, right? Again, cats to dogs here. Cats was first, so it represents the first number. All right, so I'm going to go ahead and label my first column as cats because, again, order matters. And my second column will be dogs. And how do I find total? Remember up here, how did we find total? We just add them together, right? We just added them all together. So what is 8 plus 3? Well, 8 plus 3 is in fact 11. Okay, again, I got that by adding. So let's make our ratio. So let's skip count our cats. So 8, 16, 24, 32. We can skip count our dogs. 3, 6, 9, 12. And you have two options for finding total. You can add these guys to make total. You could say 16 plus 6 and put your total here, 24 plus 9 and put your total here, 32 plus 12 and put your total here, or you can skip count on this side, so 11, 22, 33, 44. And that's easier for me because I know my 11, so I'm going to say 11, 22, 33, and 44. All right, so those are all equivalent ratios. We could put our little ratio here. Those are all equivalent ratios. And you can include that ratio symbol for your total as well. So my ratio is cats to dogs to total. And so that's what we're practicing today, guys. You can butterfly to see if they're equal. You can butterfly to see if ratios are equal. You can skip count to find equivalent ratios. And remember, to find total, we just add our two ratio pieces together. And if we needed to skip count, we could skip count our total as well. So again, go practice your ratios.